if simplicity gets merged, in the event it gets merged, it will be future-proof for a very long time, and it will cover everything we can think of right now. This is the idea of the last soft fork.
Hello, I am Cody Ellingham, and this is the Transformation of Value podcast. In this episode, I talk with Christian Lewe from Blockstream Research. Christian is working on Simplicity, a more robust programming language designed as an alternative to Bitcoin script. To own Bitcoin is to be able to spend it, and the way we currently do this is with Bitcoin script, which has challenges and limitations that mean it can be very unforgiving to work with, and it limits more complex transactions and arrangements because you cannot formally verify what will actually happen. Simplicity seeks to fix this. The project has been in the works for over 10 years and has been described by Adam Back as the last soft fork. There is some technical nuance to this statement, but as Christian shares, enabling simplicity could bypass a lot of the contentious soft fork discussions about things like covenants, as this functionality is already possible with simplicity. We talk about the proof of work and low time preference of simplicity, as well as the plans to launch on the Liquid testnet and mainnet to validate the project through actual financial use before an eventual proposal to bring it into Bitcoin. If you have any questions or feedback, please reach out. My emails are always open, hello@thetransformationofvalue.com. Otherwise, on to the show.
I was doing some research last night and I found a video, an interview you did talking about simplicity and Miniscript potentially. So I watched that.
Where was that?
It was just on YouTube. I can't remember whose show it was.
It might be the Blockstream podcast because
there was that
I was on that. That's the only one I can remember right now. I've done a lot of presentations at conferences, but when it comes to podcasts, this might be the second one. What? So it's an honor to be here.
Oh, no, you're welcome. And it was quite interesting. I saw you did a presentation the other week at mempool.space in their Tokyo office, and that was quite a cool event. You were there talking about simplicity and sort of, it really does suit a presentation format to kind of take people through the journey. But I think today I'd love to dive into it a little bit more, maybe a little bit about your work. I'm talking a little bit about Miniscript as well, because when I was doing research, I found that you're also maintaining some of the Miniscript Bitcoin stuff as well, right?
Yeah, we have, there's Bitcoin and there's Elements, which is the backend behind Liquid, the Liquid network. And all the repos, all the software is split, or it has a variant for Bitcoin and for Elements. And I'm partially maintaining the Elements Miniscript repo, which has fewer maintainers than the Bitcoin one, of course.
Yeah. Well, just zooming out a little bit, Chris, though, you're part of the Blockstream Research team. Tell me about that story. How did you come to work with Blockstream? How did, what was the background, the genesis story?
Do you know this story, or do you not know? Because it's a funny story, actually.
Okay, I'd like to hear the funny story.
Because those who know...
if you know, you know.
If you know, you know. So it has to do with Eric Sirion, who's a friend of mine.
Oh, he presented the other day, right?
Yeah. And he was in Japan because he visited me. And he was, back in the day, he was an intern at Blockstream, and then he started working at Blockstream. And at a barbecue, he wore this T-shirt, the Simplicity T-shirt. Yeah.
Is that the one with the code?
Yeah, I think
on it.
I think he had it on.
Yeah.
At mempool.space. And the Simplicity T-shirt, on the front it says Simplicity. Okay, on the back it has these formulas. So the idea is simplicity is so simple that you can implement it on a T-shirt, which was this T-shirt. We actually made it. And I was intrigued by the T-shirt. I was not a Bitcoiner back then. I was just a college student. I was studying computer science. But some of these symbols seemed familiar and interesting, and I started to analyze them on his back, on Eric's back, like tracing the symbols with my fingers and stuff. And there was someone else who was also interested, and we discussed the T-shirt. And then Eric said, if you are so interested, why don't you do an internship at Blockstream? Why don't you just write Andrew Polster an email that you're interested in this stuff. And I did that. And then I did an internship, and this is why I'm here.
Oh wow, that's quite funny. So, and where was that barbecue? Was that in Germany or?
Yeah, that was in Germany.
Yeah.
So this was, like with fellow students and stuff.
Yeah.
And it's kind of strange because I was not a Bitcoiner back then, and I became a Bitcoiner while I was working for Blockstream and in the preparation for that. And everything I know now I learned in the past 2 or 3 years, which is strange to think about.
I guess on that side, I mean, there's the computer science, the mathematical side, but is there anything in particular about Bitcoin that really captivates you, or kind of the monetary side and that sort of thing that you've come to appreciate working with Blockstream?
That's a good question. I started to work as a full-time Bitcoiner, and more things started to click for me, and I'm pretty well aligned with Bitcoin's philosophy and with the mathematics behind it and so on. It was a journey. It's still a journey, right? So initially it was mostly about the cryptography and about the mathematics and the idea that you can apply this knowledge and do something with it, like for real, not just study at university for study's sake, but actually make the world a better place, so to speak, or actually apply what you have learned at university. This was the initial motivation to start working on Bitcoin. And then it became also about the philosophy, about the libertarianism, about the idea of free money, of honest, true money, the idea that you shouldn't trust the state with your money, or that inflation is not necessarily good, and the idea that a lot of things are happening and nobody really tries to fight them, or people complain about taxes or about inflation, but they don't do anything against it, and Bitcoin can help with that. So it's a lot of things, and I keep learning more about Bitcoin.
Yeah. Well, that must be quite cool. And so you explained last time that Blockstream Research is kind of like a company inside of a company.
Mm-hmm.
Obviously Blockstream are working on quite a few things more broadly. You've got the wallets, you've got Liquid, you've got different projects. How are you guys related to the other operations of Blockstream, and like what's a day look like for you?
Yeah, I think the relationship between Blockstream Research and the rest of Blockstream depends on the particular researcher. So I think I have the fewest connections. So you could call me a pure researcher, sort of. So I'm mostly focused on simplicity and Miniscript. And I do talk to other people at Blockstream, but
you talk.
I do that sometimes, but
words are used.
But this cannot be compared to, say, Andrew Polstra, who is the head of Blockstream Research. He has a lot of connections, and Jonas Nick, who's in the cryptography team, for instance, I'm sure he's talking to a lot of the other guys. So what are the connections? For instance, simplicity will be integrated in Elements and the Liquid network. So we talk with the Liquid team.
I see.
And we have calls with them, and we manage the GitHub repo together. So there's some cooperation there, and they tell us what they need, and we tell them what we need, stuff like that. Mm-hmm. With the wallet and with Liquid, I haven't had much contact myself yet.
Yeah, no, that's cool. So something you mentioned to me last time we spoke, Blockstream Research, I guess, is thinking big here, decades-long timelines, quite big projects. And I am keen to get into simplicity and what it means in a moment. But this, the very basis of simplicity has been around for, 10 years now? Over 10 years, right?
Yeah, I would say so. It's so old that nobody really knows.
And so I just wanted to talk about that as well. I mean, you're very much in this pure research space. And so you are sort of, in that sense, a little bit more focused on these bigger ideas, these kind of longer term pieces. Is that right?
Yeah, I would say so, yeah.
Cool. So I guess zooming out a little bit, we've throwing a few words around. We're talking about Bitcoin script, we're talking about mini script, and then we're talking about simplicity. I thought you did a really good job explaining what those mean in the presentation at mempool.space, but I guess at a very high level, starting perhaps with Bitcoin script, what does that mean for you if you're sort of explaining it to someone who's maybe using Bitcoin, but they're not necessarily a computer scientist? Like, how would you describe Bitcoin script, and what are the challenges with Bitcoin script?
Yeah, so Bitcoin, it has to do with the UTXO model, right? So when someone uses Bitcoin, they have some Bitcoin, right? Some Satoshis in their wallet, and they see a number, this many Satoshis. And if you are slightly interested or technical, you will find out that actually you don't own this number, but you own so-called UTXOs that each have a certain value attached to them, certain number of Satoshis, and the set of UTXOs you own sums up to your wallet balance. This is how Bitcoin works. And when you send someone money, you actually spend some UTXOs and make a new UTXO which is owned by the person you sent the money to. So you trade UTXOs. This is how Bitcoin works. You don't trade single Satoshis or Bitcoin, but you trade UTXOs which have certain value.
And they're fungible, so they can. There's no single Satoshi that can be identified, as you know. But just UTXO, unspent transaction output. So
yeah.
The way I have had it described to me is it's like every time you spend, you're melting down the coins and minting new coins from that pile of coins, and that become those individual coins are the.
Yeah, I think it's fair. It's a fair analogy. I would be careful with the word minting and melting because it's like related to eCash, and minting sounds like you're an authority and you can mint as much as you want, like an asset or like a eCash note. So with Bitcoin, there are certain rules, the so-called consensus rules. They make sure everything works. And one of the rules is that you can only, in a transaction, you can only create the transaction outputs must sum up to less or equal the transaction inputs. So you can never create Bitcoin out of thin air. Yeah. You can only burn Bitcoin, but you can never create Bitcoin. This is an important rule.
Yeah, that's one of, I guess, thank you for that. It's sort of one of the challenges of the analogies, because it is fundamentally a different thing. But you're right. There is this, there's constraints on what actually happens there. It's not just making new money. You're sort of transforming it as it gets sent into a new UTXO. So
yeah,
and this is part of Bitcoin script, right? Is you said to me last time, to have Bitcoin is to have the ability to spend UTXOs.
Exactly. So I talked about owning a UTXO, and this is usually you have a private key which controls a UTXO, and to spend it, you have to reveal a signature, a cryptographic signature which you can only create if you own the private key. And this is verified publicly by all the Bitcoin full nodes. And then everybody sees, okay, you own the UTXO, so you're authorized to spend the UTXO in a transaction. But you can do more than that. There are more complicated ways how you can own a UTXO. For instance, very famous is multisig. Bitcoin, as far as I know, is the first system where two people can own something together, but not alone, right? So before, if you shared something, someone could run away with the money or with the owned object. But now with Bitcoin, this is impossible. So that's a revolution. And this is a more complicated so-called spending condition, or way how you can own a UTXO together and not alone. And for these kinds of complicated statements, these spending conditions, you need Bitcoin script. So it was kind of interesting. I recently read for the first time a thread on the Bitcoin Talk forum by Satoshi, I think from 2010, where he explains why there's Bitcoin script. And he says, Bitcoin, the architecture of Bitcoin is set in stone from version 0.1. And so we cannot make changes easily. So we must be flexible in how we implement it. And he wanted to implement a large set of spending conditions like the multi-sig and escrows and all kinds of things that people talk about even today. And he said, you can implement this like one after the other, and you have a long list of special cases, and the list will never be long enough. And then you have to make changes to the list, and this is very difficult. So he invented Bitcoin script to cover everything at once using the scripting system, which is powerful. It's restricted, but it's still powerful enough to express a lot of these spending conditions, and it has served us until today. And the Bitcoin script, it's just a program that says yes or no. You can spend or you cannot spend. And in mathematics, we call this a predicate. A predicate is a function that tells you yes or no. But because predicate is a long word, he called it script.
Yeah.
This is his words.
Interesting. And something you said to me as well, it's imperative. Is that right? Bitcoin script is imperative. You declare it,
yeah,
and it does it, and is it procedural as well? It's sort of line by line.
Yeah, it goes line by line, and you don't directly specify the condition. So it's like if you have a Bitcoin script in front of you, it's not, and if you're not familiar with Bitcoin script, it will take you some time to understand what exactly the condition is, because it's not the condition, it's not spelled out like that. Instead, it's implemented in a way that the machine can understand it, which is what we call imperative programming. So you implement the algorithm to suit how the machine executes the algorithm. And this is one of the problems with Bitcoin script, that it's hard to read.
Yeah, and it's worth pointing out that Bitcoin script lives on the blockchain, right?
Yes, the Bitcoin script is executed by all the full nodes.
Yeah,
which means it must be fast. There's a DDoS potential. If there is a script on the blockchain which takes a very long time to execute, then everybody will have this problem, and you will potentially DDoS the entire blockchain.
And that was another story you shared with me, talking about op eval, which was a kind of caught at the last minute by Russell O'Connor, sort of saving the day, and that was about to be merged right into.
Yeah, this is before my time, so I know less about that. But Russell O'Connor is the inventor of simplicity, and he has done a lot for Bitcoin. He's sort of unknown because he keeps to the shadows. he stays in the background. He does what he can do best, but he's not a person who goes on stage a lot. He spotted an error in op eval, which would have enabled infinite loops in the system. So op eval is like a way how we can extend Bitcoin script to make it more powerful. But there was a bug, and it became too powerful, leading to infinite loops. And infinite loops basically mean your full nodes will never finish running the script. And so it cannot do other things. The CPU will run hot. The Raspberry Pis will just die. It's not good. Yeah. So we don't want that on Bitcoin. And he pointed this out, and the merge was blocked.
Yeah, that was sort of saving the day. And then that was quite a few years ago. So it was sort of when I think maybe there were less eyes on.
I think this was 2014 or so.
On things, yeah. But I guess coming back, so we've talked a little bit about Bitcoin script, and something you said as well, you never want to touch Bitcoin script unless you really know what you're doing, right? It's a very complex thing. It's maybe not clear, as you said. It's sort of, it's a whole field to understand that. And even today, mistakes get made. People do things in the wrong order, or they don't understand the implications, and it puts conditions on Bitcoin that they didn't anticipate. They weren't. It wasn't their intention to have those conditions or to have it set up in that way. And would you say even today there's still issues with people?
Oh yeah, Bitcoin script is in the developer community. We talk a lot about Bitcoin script, and of course it's not. There are other things to Bitcoin than Bitcoin script, but Bitcoin script is huge because it touches the ownership the ownership model,
which is Bitcoin.
Which is
right?
Bitcoin. You own. It's all about owning something for real and actually owning it in some form alone or multi-sig and so on. So if you touch Bitcoin script, you touch everybody's Bitcoin.
And so I guess that's from the Satoshi days through to today. There's all of these opcodes. They live on the blockchain, and they basically enable you to set conditions for how UTXOs are spent. But then moving on from that, Miniscript comes into the picture. And so what does Miniscript do? What is the relationship between those two?
Yeah, so Bitcoin script is hard to read, and it's potentially dangerous because if you make a mistake, you cannot spend your coins. You have moved your coins into some sort of ownership system which you don't control, so they're gone. Basically, you burned your Bitcoin. And there are some things like time locks which are particularly dangerous because of some quirks and some things that can easily go wrong with Bitcoin script. So time locks, they say you can only spend your coins, your UTXO, after a certain point in time. And there are different kinds, and you can mix them. And if you mix them in certain cases, they like cancel each other out and burn your coins basically.
Really?
And this is why people didn't use time locks. So time locks are used in, for instance, the Lightning Network for like timeouts and stuff. This is where they were used and I think are used the most. But besides Lightning, I don't think anybody used time locks for a very long time because they were just too dangerous. Nobody wants to lose their coins after all. And so Miniscript came along, and Miniscript makes Bitcoin script safer to use. So it took me some time to understand Miniscript because it can be confusing. Some people, for instance, we say Miniscript is Bitcoin script. That's what we say, which is a confusing statement because it's not the same thing one-to-one, obviously. But Miniscript is not a soft fork. Miniscript does not exist on the blockchain. It's a way how we can view Bitcoin script. So I say Miniscript is Bitcoin script with a good structure, with a structure in the program. So you take a script and you look at it and you try to find some good structure in the script. If you find the structure, then you get a lot of benefits. So you can analyze the program better. You get a lot of safety guarantees. Safety guarantees such as the time locks are not messed up. And then if you use Miniscript, you can run these checks to see, is my script safe to use? Will I be able to use to spend my coins later? And doing that gives you a lot of peace of mind, which is important for Bitcoin. If you do not find the structure in the script, then bets are off. Like maybe it's safe to use, maybe not. Miniscript gives you safety.
How would one go about using Miniscript? Is it, I think of it more like a transcompiler or something, where it's sort of
like a high-level language kind of
on top, and so you would write it on your machine, and you would sort of sketch out what you want, and then that would generate the Bitcoin script that you actually then need to use. Is that sort of how it would work, or?
Yes and no.
Sorry.
No, I think from a practical perspective, this is good enough. It's a good analogy. It helps you think about Miniscript. One thing that does not work in this model, or one thing that I want to point out, is that you can go to the blockchain, look at a script inside the blockchain, and you can see the Miniscript or not. So even though it's sort of, you said it's compiled away, right? Like if I have a C program and I compile it and the C program is gone, I have assembly now or a machine code. The C is gone, right? That's what it means to compile. I change the language. Whereas with Miniscript, it's more like a macro language. So I can look at a Bitcoin script and see if I can extract the Miniscript out of it. Sometimes it works, sometimes it doesn't. It works if the program has a good structure, if it's well structured. And most programs, by the way, are well structured. Only the weird ones are not. And you should not use the weird ones.
I see. Oh, interesting. So there is, it's a slightly different relationship then. And so that's Miniscript, and that's been around for a while now. It's quite, I mean, what is the usage of Miniscript? Is it industry standard for these kinds of things?
Yeah, it is industry standard. Everybody should use it. Hardware wallets are now supporting it. And there are wallets like Liana Wallet. Those are just the ones I know. There are probably more than that use Miniscript to specifically for time locks and other features of Bitcoin script that were too dangerous to use before. So even though Miniscript does not extend Bitcoin script, so it doesn't add any features, so to speak, it still adds some functionality because you can use dangerous parts of Bitcoin script because they're now safe to use. And it is a standard, yeah.
Yeah, interesting. And then that's Miniscript. And then Simplicity comes into the picture, and that's been in the works for a long time now. And as you said, Russell O'Connor has been working on this for over a decade, perhaps at this point. And what does Simplicity mean? It's sort of, how does that fit with these other two that we've just talked about?
Yeah, so Simplicity is also a language which you can use to express ownership conditions of a UTXO. So just like Bitcoin script and Miniscript, the language, you have programs which tell you yes or no, spend or not spend. Difference, so they have all this in common. They can be used on Bitcoin. The difference is, so Bitcoin script and Miniscript, they are the same system. They use the same execution engine, and they're implemented on Bitcoin right now. They work great. Simplicity is a new scripting system which aims to revolutionize or massively improve what we have. So it's an improvement upon Bitcoin script and also an improvement upon Miniscript. It's like the high-level overview.
Yeah. And when we talk about an improvement, that you mentioned some of the dangerous aspects of kind of user beware or developer be aware when working with Bitcoin script. What other improvements besides that sort of danger mitigation do you get with Simplicity?
Yeah, I think this will go into the danger mitigation thing again. But I would say the highest selling point or the biggest selling point of Simplicity is its safety, because Simplicity is formally verifiable. So it's verified software. This means we have a specification written down mathematically precise, what the execution engine should look like, what a program should look like, what the program should mean. It's all laid out. And then when we implement the runtime, which runs the programs, we follow the specification and we can check if our code fulfills the specification. And doing that, first of all, reduces the potential for bugs immensely, right? So there's basically no undefined behavior anymore.
Yeah. That is critical here because, Bitcoin is your ability to spend your UTXOs. And if you are locked out of that because of some quirky script setup, then, and for most people, they're just doing a single sig, a multi-sig, very standard stuff. But one of the examples that I read about in an article was, say you have a large corporation with a very large multi-sig setup, and maybe every individual director who has access to that multi-sig wants to be able to interface with it with their own multi-sig or their own kind of setup. And currently, there wouldn't be a very easy way for them to verify whether their access would actually be able to unlock their part of the multi-sig. And what you're saying is with Simplicity, because it's formally verifiable, they can prove, or that can be proved to them, that their setup would unlock their part of the UTXO multi-sig. Is that sound right?
that would work. Of course, verifying this sort of stuff is work, but at least it's possible. Like Simplicity gives you the tools and the ability. On Bitcoin script, it's also sort of possible, but it's even more work.
Yeah.
So Simplicity just raises the bar for security on Bitcoin. That's point number one. It gives you this mathematical security, this specification, which you can rely on. And how should I put it? We need the security on Bitcoin, right? It's about millions of dollars,
billions,
trillions. And so we rely on code, right? Like we never did a hard fork to fix bugs, which I think is for the best. And so this means if you have a bug in your code, this is consensus, right? So the only way how you can protect yourself is to make sure the code is correct. But as you know, humans make mistakes all the time. So it's good to have some checker, which is like a sanity checker, which says your script is sane, your programs will work, be like, you can't sleep now.
I guess outside of the Bitcoin world, this framework, I don't know what we would call this, but the thing that simplicity is, this mathematically, formally verifiable system, is there any other context where that is used? I'm thinking, within, say, rocket science or some other place where it is mission critical to have this formal verifiability. Is there anything that you're
It's a good point. Yeah, actually, it's used in space. It's used in the Mars rovers.
Yep.
It's used by governments. They don't use simplicity, of course. They use, I don't know, actor or I like ADA. I keep forgetting these names, but something with A.
So there's a paradigm or a precedent for this thing. What would you call it generally? This category of language, is it? Or
yeah, it's a functional language. It's simplicity. I would say it's a declarative language, and it has these well-defined semantics. Semantics just means what the program means.
Yeah. And again, sorry, appreciating I haven't got a computer science background, but I think the analogy of the idea that you know what it's going to do and you can prove that it's going to do that thing is really a key takeaway here. And I guess coming back to Satoshi's original work in the early Bitcoin opcodes, how would you describe, just based on your experience, the design paradigm that Satoshi used? Do you feel like maybe there was his approach to using the opcodes, that kind of original paradigm that was set that back then? How did that come about, do you think? Was it a pragmatic decision because it was the easiest way to do it at the time, or?
I think it was very pragmatic, and I think it is an elegant design that works. It's been working for since 2009.
Yeah.
So that's amazing. And if we had some small bugs, but no major ones, so that I'm aware of right now. So that's great. One of the problems with programming languages is they are too powerful. There are a lot of languages like C. Maybe you've heard of the C language. It's maybe the most well-known, or Python. Why don't we use Python on Bitcoin for the scripting? Because we have all these tools, right? And why invent a new language? And the answer is these languages would have infinite loops, which is bad. Again, the full nodes never finish. So you DDoS Bitcoin, you kill Bitcoin like that. We don't want that. So we create a very limited language, which is very efficient. It does only what you want, which is to lock and unlock the UTXOs to express these conditions. So you have some cryptography, some hashing, some signature operations that are not native to Python. You can do this, but you need library. In Bitcoin script, you don't have any libraries. You just have the opcodes. And this is why Satoshi invented Bitcoin script. It's a very small language. It only does one thing. And it's easy enough it's predictable enough, easy enough to think about it. Simplicity is better, but Bitcoin script is much more predictable than Python or C or any of these languages.
Yeah. Now that's really interesting. And I guess the other thing that sort of stood out to me watching your presentation and talking to you was sort of over the last few months, there has been more and more discussion around covenants and what that means. And you sort of shared with me some insight into that, because these covenants, they tend to reuse or use existing opcodes that aren't currently being used. Is that right? So
they introduce new opcodes. It's fair to say.
They're introducing new opcodes, but there is a limit to the number of opcodes. Right?
Yeah, it's a technical detail, I would say.
Okay.
it has to do with the soft fork, right? So you can only
tighten.
You can only tighten the rules.
Yeah.
So there must be some sort of rule about non-existing opcodes. And how this works is in Taproot you have op success. There are actually multiple ones. For every gap, for every opcode that's not defined, it's an op success. And when an unupgraded node sees this, it will just say, okay, success. I don't do anything. As far as I know, I think it's a non-operation. Yeah. And in the soft fork, you say, actually, I tighten the rules and say covenant stuff or a signature or whatever. Do a new thing, which is a new restriction in the script. So it's a soft fork.
Yeah,
this is how it works. But like from a user perspective, I think it's easier to think about it as an addition of a new opcode.
Okay, so we've had this conversation around, or there's been this conversation around the challenges with high fee environments, UTXO sharing, the future of the Lightning Network, these kinds of questions, and covenants and the various covenants proposals have emerged, and there's been people talking about them, people have been shilling their own covenant idea. There's a whole lot of options. And from your explanation to me offline, my understanding is that simplicity does away with a lot of that controversy, because if you can think that you can do it, then you can do it on simplicity. You don't need to have another soft fork for each thing that you want to add.
Yeah.
Would you say that is a correct?
I think that is correct. So simplicity has been in the making for a very long time, 10 years plus. And one of the takeaways until now is that it's not obsolete yet. It's still a good idea, which is amazing given everything we've seen in the past 10 years. So simplicity is a very, how would you say, like, it looks very far into the future. It fixes a lot of problems for Bitcoin script. And it's superior to the small proposals right now.
Because, there's this... there's this kind of idea that, we've got, we had SegWit, and then we had the Taproot soft fork, and there's these epochs of soft forks. But talking about covenants, and there's certainly a lot of discourse around what is wrong with certain covenant proposals, which one is the right one, and it seems like it may be increasingly difficult to get, people behind a soft fork, whereas simplicity, you've described it before as the last soft fork, and perhaps in a bit of jest, but certainly it kind of, from what I was reading, it enables you to do stuff like Schnorr signatures, right? Is it?
Yeah, it does that. I mean, we have Schnorr signatures now using Taproot, right? But
if we didn't have Taproot, you would have been able to do it with simplicity without.
You can do BLS signatures, or you can do other kinds of signatures. Or you can do cryptography that doesn't exist. You can do like a SHA-3 hash if you want. Right now we use SHA-2. The last soft fork, those are Adam Beck's words, by the way.
I'm sorry.
I repeat his words.
And I repeat his words.
So I think it's an interesting term. I had to wrestle with this term because I'm German, and so the first thing I say is this is incorrect. It's not correct because it's not. Simplicity is obviously not the last soft fork. There will be security patches, and maybe there are things we cannot think of right now. There are things outside of the scripting system.
There was that Unix timestamping.
Yeah, we will have a hard fork at some point, which would be very interesting.
Yeah.
But simplicity is still the last soft fork in a way, because it makes a lot of the proposals that exist obsolete, like you said. So it's just so much better than what exists right now that you don't need these small proposals anymore. You will just have a big update, which will cover a lot of use cases and which will be very much future-proof for a long time. And if you need to upgrade simplicity, you can do that, and then you have another soft fork. But the idea is that if simplicity gets merged, in the event it gets merged, it will be future-proof for a very long time, and it will cover everything we can think of right now. This is the idea of the last soft fork. Mm-hmm. And we will have, obviously there will be a lot of discussion about what do we want on Bitcoin, what should be covered, What are the use cases we want? And this discussion needs to happen before we even think about merging simplicity. Right now, we will merge it on Liquid first, and the merge on Bitcoin, although planned, is again far into the future from now.
So I do want to talk a bit more, or we can come back to talking about what is possible with simplicity. But you just mentioned the deployment plan with Liquid. So already, is it on Liquid testnet, or it will be on Liquid testnets shortly?
It's not on the official testnet. There's like a separate testnet. I'm not completely familiar with how many testnets we have, but I don't think it's not on any of the official ones.
Okay.
Or the main ones. It's public as far as I know, but it's not the main one.
But you're looking quite seriously at moving it to the public testnet.
Yeah, and also the mainnet, liquid mainnet.
Liquid mainnet. And
the sidechain.
And this, you explained it to me, because the Liquid is a sidechain, but it still uses the witness header setup. It basically would plug in just like with Bitcoin. Is that correct?
Yeah, so it's like we can merge simplicity in many ways. So in a way, it's a technical detail, but right now we think about simplicity as living inside Taproot. So Taproot has versions. So there's SegWit, which has versions. There's SegWit version 0, and then there is SegWit version 1, which is Taproot. And Taproot, again, has versions. And these versions basically dictate the rules, mainly for simplicity, let's focus on the scripting system. So you could change the rules of the Taproot scripting system by introducing a new version. And simplicity, you can just define as a new version and make up your own rules, which are the simplicity rules. And there you have simplicity merged. That's how we merge it. We could merge it in different ways. Yeah.
Okay, and so that's Liquid. And I guess coming back to the implementation of it, you're able to do this with Liquid, and so there's a lot of this kind of noise, and it's died down a little bit as fees have gone down, but certainly earlier in the year, everyone was talking about covenants and, the next soft fork and when's it going to happen, blah, blah, blah. What I'm seeing here is you guys are doing the work. It's been in the pipeline for a very long time, and by actually bring it into Liquid, it sort of brings it a lot closer to a kind of a proof of concept, or a very strong position to show that it's actually able to safely custody value and manage things. So starting with the testnet and then mainnet, whereas what you sort of could describe some of the Covenant proposals are kind of hobbyist, updates. They've been tried out, but maybe they haven't had a proof of concept or an actual testnet deployment made and that sort of thing.
Yeah, you mentioned two really good points. So I will first talk about what you called hobbyists. Yeah. I mean, now it's hard for me to find a better word. It sounds insulting. It's not meant to be insulting, of course. But the idea is that, the Covenant proposals they basically have two problems, the existing ones. So either the proposal is to limit it, like OpsiDV, so people don't want to merge it because it adds Covenant, which is sort of big, but then you don't have so many use cases. So you would like a bigger update, which it's a lot of effort to make a soft fork. Because exactly. So making a soft fork is work. Adding covenants is like a big step in Bitcoin. It's completely new, so you want to do it right, and you want to get some use cases out of it to make it worth the effort. This is the first problem. The second problem is if it's a big update, you don't know if it's safe.
Yeah.
So it's like a catch-22, right?
Yeah.
It's like what do you do? Big or small? Small is not big enough. Big is too large. And simplicity comes in. It's a big update, but because it's verifiable, it's actually safe. Yeah. That's the cool thing about it. That's why it's not hobbyist. It's actually professional.
Yeah. Well, and I think the other thing, again, my understanding of it was we're at a point today where the clout of Twitter influencers, of kind of, Bitcoiners talking about stuff. And again, I'm not a computer scientist or advanced mathematician, and so I don't have a technical opinion on this. But there's a lot of people who have opinions, though they might not have a technical background. And so there's stuff floating around about how covenants might, you might lose your Bitcoin to a black hole of, covenant inception or blah, blah, blah. And you explained it to me that we already have covenants in the sense of something like a multi-sig.
Yeah, exactly. So if the government wants to KYC you on Bitcoin by forcing you to stay inside some sort of covenant, they can do this with multi-sig. So every time you spend your coins, the government must sign with you. And if you do something they don't like, they will not sign. You can do this right now.
And I could, my evil brain actually can see how that would work. You would just have in the apps, your wallet app on your phone, when you click the send button, it would go and query the government server. And it would, and if it's a safe transaction that they approve, then it would sign on their end and your end. And if it doesn't want to approve, it won't sign on their end.
It's scary, and I can see this happening in the fiat system as we speak. Like it's really dangerous. It's really scary. So it's possible on Bitcoin, but it's also possible to avoid it by not using a multi-sig with the government.
But I guess the point though was the soundbite of the covenants, your Bitcoin being locked into these covenant things, that's kind of quite a mimetic thing that people can pick up on and be like, okay, I don't want the covenants that give too much functionality. And so there's kind of a challenge there, because you can do quite a lot of stuff with simplicity, and you can do quite a lot of stuff with some of the larger, I believe Opcat has got quite a lot of functionalities like that, right?
On its own, I'm not sure if it does a lot. Like Opcat,
it's a set,
it just combines two things into one thing. So AB, it makes AB.
Yeah.
It's something like that. And usually it's Opcat is used in conjunction with other opcodes like check sig from stack, which is just a signature check. And then with Opcat, you can suddenly sign and verify arbitrary parts of the transaction, basically. But Opcat on its own doesn't do a lot.
Yeah. So, and again, sorry, we're hitting the limits of my knowledge here, but in terms of the discourse around, well, look, if we enable this, it's kind of, we don't know, we're opening Pandora's box. And I think the alternative here with simplicity, as far as I can see, is that it gives you that formal verifiability. And we've already established that if the government wants to put you into a 2 of 2 multi-sig, that's already possible. And so it's sort of like how to communicate that in a way that makes sense, because I think there's still a lot of those kind of ossification, don't touch anything, and sort of challenging kind of dynamics around consensus that would take a bit of effort to overcome.
I think there's also misconception about covenants and scripts, and this misconception is that you don't know the covenant, right? Like the government or someone forces you to keep your coins in some sort of system, but you don't know what the system is. Because usually if you go to your bank, you don't know how your bank works. You don't know how the government works. So this is the status quo right now. But on Bitcoin, everything is transparent.
We can see it.
Which is the amazing. It's the idea of public verification. And simplicity and covenants and Bitcoin script work exactly like that. So even if the government or someone forces you, at least you know exactly the conditions. And with simplicity, it's also about transparency. So you have this formal verification, which just means everything is very clear. You know exactly what your program does. I said before, there's no undefined behavior. Undefined behavior is when you don't know what your program will do because it reached some sort of edge case, some sort of bad state, and you don't know what will happen, which is bad for your UTXOs because you don't know who owns your UTXOs at that point.
Well, and I think that's sort of what's becoming clear to me is on the hypothesis that Bitcoin runs the world's financial system, there is going to be edge cases, most certainly, between super large multi-sigs with time locks and all sorts of things, in the mix. And these things are going to be custodying, huge amounts of value, nation state level, amounts of value here. And not being able to verify that is actually, it's almost holding back maybe some of these innovations, because you just can't trust that it's going to work. And so maybe we're limited to some of these more basic use cases, whereas with something like simplicity, as far as I can see, you could have these large, kind of quite complex arrangements that are working, and you can prove that they work.
Yeah, I think we need something like simplicity on Bitcoin. As Bitcoin matured and as more and more money poured into the system, the standards rose for the code base. So you can look at early BIPs and the early code base, and it's good, but it's nothing compared to what we have now. The BIPs get more and more professional. There's more mathematics. People with PhDs are working on this, and money pours into this research. I'm also a researcher, so we spend a lot of time and money on improving Bitcoin and raising the standards. And formal verification and this like mathematical approach, this rigorousness, is a new standard for Bitcoin. There's also an example with you can look at Taproot. It's a very professional BIP. And one of the things that Jonas Nick and others are working on are these aggregate signatures. And as far as I know, Jonas wants to make this a formally verified BIP. So the BIP will have some sort of specification which is clearly stated in mathematical language. And then you can use tools to prove statements about the BIP, and you can check if you correctly implement the BIP, which is not possible with Taproot and with the other BIPs that exist right now. With Taproot, you have to read the bullet points and hope you did everything right. And if you didn't do something right, then you will probably hit an error at some point, but you don't really know if you will ever hit an error.
So something I was reading about is we can think of these complex transactions as a tree-shaped program where you can, sort of go down different pathways, and you can have, say, a multi-sig and then a multi-sig and then other things nested in it. And this, maybe this is a new way of thinking. Certainly for me, it's a different way of thinking. But the edge cases that you get to when you've got time locks, different kinds of multi-sig setups, things nested inside each other, that is extremely difficult to prove. It's kind of really come back to this danger mitigation. And so you're going to be reluctant to implement something like that, even though that's kind of what you want, is you want to be able to do this.
So you mean Bitcoin script?
In Bitcoin script at the moment, yeah. Would you say that's
because in Bitcoin script you can, with miniscript you get this tree structure, which gives you some security. But in miniscript, I would be happy and okay with using a complicated setup that you just described. I think you can do this. With Bitcoin script, it's just unsafe. It's reckless because you don't know which parts of the program influence other parts. You can analyze it, but it can get very complicated very quickly. So don't use raw Bitcoin script, use miniscript. But with miniscript, you have certain limitations. For instance, you cannot do covenants, of course. So then you need simplicity.
Yeah. Okay, and I think we talked a little bit about your rollout plans for bringing this onto Liquid, and I think certainly before I met you, Chris, I didn't actually know about simplicity, and I haven't seen it discussed, to be fair, in the channels that I follow. Maybe there's more talk on the technical forums and things like that, but in terms of your guys' approach to bringing this into Liquid, and then maybe longer term, the push to bring it onto Bitcoin itself, is there a kind of a strategy around what that looks like, or is it really still just step by step, starting with Liquid? Like, how have you got any thoughts on that?
I think our strategy with introducing simplicity to Liquid is with liquids, we know what we're doing. Not many people know simplicity yet, but once we have simplicity on liquids, people can start using it. It's opt-in. You don't have to, no coins are at risk unless you opt in. And simplicity is the most secure code base basically that exists. So arguably there is no risk, but it's a new system. So maybe you do something foolish and burn your coin. So it's opt-in. And the idea is, if we will show people what they can do on liquid using simplicity, using real money, real assets, which is a real proof of concept. It's not a toy anymore. It's like but it's also not the Bitcoin mainnet. It's something in between. And people will start playing around with this, and they will see the potential for simplicity. And then we can start discussing Bitcoin.
Yeah.
And we can discuss like, what features do we want? What about the security, the verification? Is it like easy enough? People will try to verify some programs. They will check our code base. People will talk more about this. Right now, like you said, almost nobody's talking about simplicity because it's still this niche topic. And frankly speaking, for a normal person, it's hard to like get an overview of what it can do, because it can do a lot. It's a big update, and you have to wrap your head around this.
Yeah. Well, I think this is perhaps this is by design, the way you guys have approached this, but I think this is an incredibly smart move. I think the word covenant is just, it's like a knee-jerk reaction. I think people they get a feeling in their gut, and especially if they're, maybe they're non-technical, but they are running their own node, or they're sort of involved enough to be like, look, I don't want to change anything. But by running it on liquid and getting to a point where it's being used for large amounts of value on the liquid side chain, it kind of is the proof of work that, if someone wanted, if there was an exploit or there was some issue with it, that would, or there was a bug that would manifest on this side chain, and that can run. And if it goes for a year or 2 years or longer without any issues whatsoever, then that's the proof of work that this thing is good to go. And I think that's a much more powerful position than some, BIP, pull request on GitHub that, maybe is being deployed to testnet Bitcoin, but it hasn't had, the ability for people to actually run it and have financial value at stake. So, I mean, for me, that stands out as a really kind of just an alternative to this whole covenant discussion, to the various, soft forks that are coming out. I'm excited to see what happens.
People vote with their money. People can say a lot, but when they use money, their own money, on something, they really like this something.
Yeah.
Money doesn't lie in this sense. And of course, Bitcoin is about it's a financial system. It's about money. So if people lock huge amounts of money in simplicity contracts, then this is a proof of work, a proof that they believe in the security of the system. This is the opposite of talking bullshit for or against the proposal.
Yeah.
Which is great.
Yeah, and at the end of the day, I mean, if you've got maybe sort of it gets deployed to Liquid, maybe some wallets start using simplicity code in there, even just for, simple functions, single sig transactions and things. Is that a correct way of talking about it, by the way? If we're talking about Liquid.
Yeah, that's okay.
That's good. Okay, language. Maybe you get stuck in some wallets, you start getting integrations, and that ecosystem can start to emerge. And we're starting to see with stuff like Aqua, where it's Liquid and Bitcoin kind of in the same user interface. That could certainly be sort of the new vehicle for communicating this idea. And then this sort of longer term, it just enables a lot more functionality. You don't have to have these sort of every 4 years, there's a kind of a new soft fork coming out, or some kind of idea that someone's come up with. It's already possible with simplicity. You just need to code it up.
Yeah. Simplicity is also configurable. So if for some reason we hate covenants very much, and somehow the community consensus emerges that we don't want any covenants on Bitcoin, we can actually not have them in simplicity as well. We can remove them. Yeah.
How would that work?
Yeah. So covenants always look at the transaction you are making. So you spend inputs and you make a new transaction. And the covenants are all about the outputs of the transaction you make. The new ones, right? The future UTXOs. And they restrict what they look like, the future UTXOs. So, there are certain commands that look into those outputs, which enable you to say, this looks good or this looks bad. If these commands don't exist, you cannot look into the outputs. And then you don't have covenants. So this is called introspection.
So that you talk about configuring that. So say it got deployed, the soft fork is done. Then at some point it's decided that covenants are not wanted.
Oh, that will be bad. So it's like,
sorry.
Simplicity is like Bitcoin, right? If you cannot change it, basically.
Yeah.
You can do soft forks and you can have versions, but you always have the old version. So the idea is simplicity has a list of commands, and some of them are the so-called introspection.
Oh, and you could tighten that list.
You can tighten the list before you make the merge, and you have a list for Liquid. You try out this list, see how it works, see if people want to make changes, and then if people like simplicity, you merge an updated list into Bitcoin. And this list might or might not include the introspection, of course.
I see. Yeah, I was going to say, so you go, you have everything on Liquid and you see what happens. And if there is these cases where things are, people are really not liking the covenant thing, it's starting to not work out, when it does come time to propose to move it into Bitcoin itself, you can remove the introspection option.
And certain things maybe people want to add things. Maybe a certain thing is possible but very quirky and complicated. Then you can add a new shortcut command that is like easier to use to the list. So you can add things, you can remove things.
Yeah. Wow, that's powerful. So that for me, that sort of stands out as another reason why this approach of using Liquid as the test, or maybe test isn't the right word, using Liquid as the proving ground for what you guys have been working on is a really good idea, because you can see how it's being used in the real world. Maybe there's use cases that haven't even been thought about yet that maybe cause issues, or there's conveniences in there that you would like. And that can, that's the proof of work. That's the place where it's verified, and then it can come into Bitcoin at a later date.
And also this needs to happen, this proof of work, because I want to highlight again how big simplicity is as an update. We said never touch Bitcoin script, or if you touch it, you must know what you're doing. It's a big simplicity is a big update, and we must handle it with care. Simplicity is all about being careful, being mathematically precise, not making mistakes, not breaking Bitcoin. That's the number one priority. And so we need every proof we can get before we merge it into Bitcoin. And the Liquid is a great testing ground. We need more eyes on it, and Liquid will provide these eyes. Liquid will expose people to simplicity if they want to be exposed. Will be new software, and the ecosystem, like you said, will emerge and will develop, and then we can start working on the BIP, which will bring it to Bitcoin and which will make sure that we don't break Bitcoin in the process.
Yeah. Well, look, man, I'm interested to follow that story, and I think that's also a whole nother thing, what activation methods are used and, how is it communicated and these kinds of things, but that's still a long way away.
Simplicity is like a very low time preference story. It's been around for 10 years, and likely it will be around in the next 10 years. Maybe merge, maybe not, but it will not be just sudden. It will not suddenly vanish because we found out, it's actually bad.
Yeah.
And we take our time to make sure everything is right, because Bitcoin is here to stay for hundreds of years, and we cannot change it easily. And we do soft forks only. So if we do an update, it should be right.
Yeah. Well, hey, Chris, thank you for sharing your work on this. It's very inspiring. I'm sort of standing in awe in front of the pyramids of work that is being done by yourself and others, and I can only appreciate it because it's I mean, it's incredible stuff, and it stands out to me as showing just the level of commitment, the security focus, the long-term vision that Bitcoiners share. And yeah, man. So I guess just sort of wrapping up. I mean, what's next for you? You're in Japan at the moment, but you're going to be heading back home and sort of working more on this. I guess your holiday's coming to an end soon.
Yeah.
Any sort of just other stuff on your horizon?
Yeah, we're currently working on a high-level language for our simplicity. We call it Symphony, and it looks like the Rust programming language, which is very popular in the Bitcoin space and in the cryptography space, because it's a language that is secure to use. It's also a high security language. Simplicity is hard to write. It's great for Bitcoin. It's very small, but it's not ideal for the programmer. So we're working on a high-level language called Symphony, which will make it a lot easier to develop simplicity. And then you can compile Symphony to simplicity and run it on your full nodes and run it on the blockchain.
So this would be people working on wallets or systems, they would use something like Symphony to actually build the logic, and that would compile down into simplicity.
Yeah, and I'm working on that right now. There will be, well, it's all public, so you can check it out right now, but there will be a reveal at the Bitcoin++ conference in Austin, Texas. And I will also give a workshop in Prague, at Pizza Day Prague, about it. So, and I'm sure also other venues. So this year will be great for simplicity. I would say stay tuned for more. And while we are merging simplicity into Liquid, we are also developing tools so developers can start to use simplicity and not be confused.
Yeah. No, that's great, man. Hey, look, I really appreciate your time, Chris. And let's wrap it up there. But thank you very much.
Thank you.
Thank you for listening. I do hope you enjoyed the show. I am Cody Allingham, and that was the Transformation of Value. If you would like to get in touch, please send me an email at hello@thetransformationofvalue.com, and I will get back to you.